Welcome to Factory on Air by DBR77, where smart manufacturing gets real. This is Episode 3, Predictive Maintenance, Ending Unplanned Downtime. What if your machines could tell you they're about to fail before it happens? In this episode, we explore how predictive maintenance is changing the game in manufacturing, replacing reactive chaos with intelligent prevention. You'll learn how AI-powered insights, vibration sensors, and real-time monitoring can help detect hidden risks, extend machine life, and slash emergency repair costs. We'll dive into real-world case studies from plastics to steel to logistics and show how DBR77's predictive module gives you a clear path to fewer breakdowns and better planning. Factory on Air is brought to you by DBR77, the AI-driven platform that connects digital twin, IoT, and automation, all in one ecosystem built for the future of manufacturing. Let's jump in.
Okay, let's unpack this. Imagine a world where your machines don't just, work, but they actually talk to you. They might whisper about a loose bolt or hum about a tired bearing, maybe even send an urgent text message warning you about an impending failure. And all this before anything actually breaks. That's not some futuristic fantasy, right? It's the profound promise of predictive maintenance. And today, we're taking a deep dive into how it's rapidly becoming a widespread reality across industries.
Precisely. Yeah, the concept might sound simple on the surface, but the impact of unexpected failures in industrial operations it's immense.
Yeah.
And frankly, often underestimated.
Right.
Think about it, every halted production line, every missed deadline, the resulting strain on supply chains that scramble for emergency
Oh,
repair.
yeah, the headache.
Exactly. And that relentless ripple effect across an entire business. These aren't just inconvenient, they're incredibly damaging, often hidden costs. So this isn't just about saving money, though it does that. It's about fundamentally transforming operational reliability, shifting the entire paradigm from, let's say, chaotic reaction to intelligent, data-driven anticipation. It really fuels competitive advantage.
Absolutely. So our mission in this deep dive is to kind of pull back the curtain and reveal precisely how predictive maintenance, or PdM as people call it, how it works from the ground up. We'll explore everything from the intricate process of collecting that raw, real-time data to the sophisticated algorithms, the AI analysis that turns that data into, actionable insights. And then we'll connect it all to a comprehensive platform like DBR77. We want to show you how a leading solution integrates these cutting-edge technologies. Our goal is really to demonstrate how a smart, data-driven approach can turn all that uncertainty into incredible efficiency, ultimately helping to eliminate those costly, unpredictable production stops.
And you could expect a clear and engaging journey ahead, I think. We'll begin by laying out the essential fundamentals of PdM, just understanding its core principles. Then, we'll delve into the critical, almost magical role that artificial intelligence plays in making these predictions a reality, the brain behind it all.
Right, the intelligence part.
Exactly. And finally, we'll see how a platform like DBR77 builds an innovative, holistic ecosystem, one that not only tackles the complexities of digital transformation, but also specifically addresses the common challenges businesses face, when adopting advanced digital capabilities, making them accessible and truly impactful for companies of all sizes, which is key.
So let's kick things off with the absolute basics then. What exactly is predictive maintenance? To me, it sounds like being proactive, but incredibly smart.
Yeah.
Proactive, moving beyond that frustrating fix it when it's broken, chaos, or the often inefficient just-in-case scheduling that has plagued industries for so long.
That's a perfect way to put it, actually. At its heart, predictive maintenance is a sophisticated strategy, right? It leverages operational data to predict machinery failures before they actually occur. It's not just guesswork or, hoping for the best. It's informed forecasting. It's a truly scientific approach to anticipating the future health of your critical assets. And to truly grasp its revolutionary power, we really need to compare it to the traditional maintenance models, the ones that have dominated industrial operations for decades.
Okay, and what exactly are those traditional approaches? I think most people are familiar with the basic idea of fixing something after it breaks, unfortunately.
Yeah, that's the most common and be the most rudimentary approach, reactive maintenance. It's exactly as it sounds. You wait for a machine to break down, and only then do you fix it. Imagine a crucial component on a vital production line failing unexpectedly. The immediate impact is a complete unbudgeted halt in production, which means lost output, lost revenue.
Total chaos.
Total chaos. This inevitably leads to frantic emergency repairs, often at premium, inflated costs for parts, and specialized labor. You're suddenly rushing orders, disrupting your entire schedule, your supply chain. It's costly, it's inherently chaotic, and it always means significant lost production time. It creates a domino effect across the business.
So it's essentially firefighting, constantly reacting to emergencies. Okay, how does that compare to preventive maintenance then? That sounds like it should be better.
Preventive maintenance is certainly a step up, yeah. It's an evolution, but it still comes with significant limitations.
Right.
With this approach, maintenance is performed at fixed, rigid intervals, maybe every 500 operating hours, or perhaps once a quarter, even annually. The key here is that it's done regardless of the machine's actual real-time condition.
Oh, okay.
The theory is sound, right? Prevent failures by servicing components before they might break. However, this often means maintenance is performed too early. You're replacing parts that still have plenty of life left, leading to unnecessary costs, wasted labor, avoidable downtime.
Or worse.
Or, conversely, and perhaps even more frustratingly, it can be too late, meaning a critical component still fails before its scheduled service, which leads right back to the same disruptive and costly breakdowns as reactive maintenance.
So predictive maintenance truly optimizes everything then. It hits that sweet spot between unnecessary costs and catastrophic failures.
Absolutely. That's the PdM Advantage. It uniquely optimizes both maintenance cost and machine availability by performing maintenance only when it's truly needed. This precision is based on continuous real-time condition monitoring. It's all about data-driven decisions, ensuring resources are deployed at the exact optimal moment. This prevents both waste by not doing maintenance too early and catastrophic failures by preventing breakdowns before they happen. You're intervening with surgical precision, maximizing uptime and minimizing operational costs.
That makes perfect sense. It's like having a doctor who not only knows when you're about to get sick, but also tells you precisely what diet change or medication to take to avoid it entirely. So if data is the key to this, how does that analysis actually fuel PdM? What's the process from, raw sensor data to a concrete prediction?
Well, what's truly fascinating here is the journey of these diverse data streams. From a machine's subtle tremors, maybe, to its energy usage patterns, they all converge to paint a dynamic, living picture of its health. And that allows us to predict its future with remarkable accuracy. The crucial first step is continuous data collection from various, often highly sensitive, sensors strategically monitoring key machine parameters. Imagine these silent sentinels meticulously placed throughout a factory. Temperature sensors on motors, vibration sensors on bearings, pressure gauges in hydraulic lines, or even sensors tracking the energy consumption or like acoustic emissions of a specific pump.
So these aren't just one-off readings, right? They're constantly feeding information minute by minute, second by second.
Precisely. They generate vast quantities of raw, real-time data, a true data deluge. And this is where advanced analytical systems and artificial intelligence algorithms truly come into their own. They act as the brain of PdM, consuming this torrent of sensor data and processing it at a speed and scale simply impossible for human analysis. The core analytical task, then, is to identify subtle anomalies, evolving trends, and specific patterns within this data that indicate potential wear or stress or an impending problem. This goes far beyond simple threshold alarms. For instance, a slight continuous increase in vibration that's still within what a human operator might consider normal for a machine. When combined with maybe a subtle temperature fluctuation and a marginal, almost imperceptible increase in cycle time, well, that might signal a very specific type of bearing degradation to an AI algorithm.
It's like the AI isn't just listening for the machine's faintest whispers of distress. It's putting together a symphony of tiny, disparate signals that a human mind might just miss entirely.
Exactly. It's about detecting complex relationships and deviations that are imperceptible or maybe meaningless in isolation to the human eye, or even a simple rule-based system. Based on these identified patterns and trends, leveraging techniques like machine learning and predictive modeling, the system can then forecast when and where a failure is likely to occur. And this allows for planned, precise intervention, transforming a potential crisis into a manageable, scheduled task.
That's truly incredible. But for many people listening, it might be hard to visualize why an industrial machine would break down in the first place. Can you give us some common, relatable examples of machine failures and tell us what kind of data helps reveal them?
So it's not always a sudden bang, right? Sometimes it's these quiet indicators, these whispers from the machine that PdM systems are uniquely designed to listen for. Indeed. It's rarely a dramatic, sudden explosion in a well-maintained factory setting. Many industrial machinery breakdowns are actually the culmination of gradual degradation. Small issues compounding over time until they reach a critical point. For instance, a very common issue is the wear of mechanical components like bearings, belts, or gears. These are often revealed through highly sensitive vibration monitoring. Even minute changes in frequency or amplitude, a tiny wobble, a new hum perhaps, can signal developing issues. Or you might see subtle temperature changes caused by increased friction as parts wear against each other.
So kind of like a creaky joint in our own bodies getting hotter as it struggles?
A very apt analogy, yes. Then there's overheating, which is a critical failure mode, particularly in motors or electrical components. This is directly and precisely measurable by temperature sensors. A sudden or sustained increase in temperature is a clear indicator of excessive friction, maybe an electrical overload or an impending component breakdown. Another common, yet often insidious issue is contamination in hydraulic and pneumatic systems. This might not immediately manifest as a breakdown, but it can significantly affect pressure levels, fluid flow rates, and eventually lead to increased temperatures or abnormal cycle times due to increased resistance in the system.
Right, like grit getting into the oil or something slows everything down, causes wear.
Exactly. Imagine grit getting into the oil. It slows everything down and causes wear.
What about those issues that aren't purely mechanical, like maybe human error or setup problems? Can the system detect those?
Those, too, can be remarkably detected by a comprehensive PdM system. Improper calibration or operator errors might not seem like a data-detectable problem at first glance, but they absolutely manifest as abnormal machine behavior. This could be unusual cycle times, unexpected energy consumption spikes, or maybe unique vibration patterns that deviate significantly from the machine's healthy optimal baseline. The system learns what normal looks like, you see.
Okay.
So any deviation flags a potential issue. And of course, there are excessive vibrations and mechanical oscillations themselves. These are directly monitored by vibration sensors and are a highly sensitive and often early indicator of underlying problems like imbalance in rotating parts, misalignment between connected components, or defects within bearings. These are, in essence, the machine's clearest cries for help, and sophisticated PdM systems are designed to hear them loudly and clearly, allowing for prompt intervention.
It's clear that the more specific and granular data points you collect, the better and more accurate your predictions become. Can you elaborate a bit more on the essential data points, the ones that are most valuable for predicting failure, and explain why they're so significant in giving us that predictive power?
Yeah, and this raises an important question for you, the listener, especially if you're thinking about your own operations. Understanding these key data points can help you identify what's truly crucial to monitor for optimal performance and proactive maintenance. First and foremost, vibration monitoring is paramount. It's an incredibly sensitive and often the earliest indicator of mechanical wear, imbalance in rotating parts, misalignment between connected components, or bearing issues. Even minute changes in vibration patterns, perhaps a new frequency emerging, or a subtle increase in amplitude at specific points, can signal major problems long before they become audible or visible to a human. This is frequently the very first alarm bell a machine can ring.
So it's not just, is it vibrating, but a deep analysis of how is it vibrating and what story is that vibration telling us?
Precisely. Exactly that. Next, temperature is an equally critical parameter. Sudden or sustained increases in temperature within a machine or component very often signal friction, an electrical overload, or the rapid degradation of a component. Think of an overworked motor drawing too much current, or a bearing running dry and grinding the excess heat is a direct, undeniable symptom of inefficiency or damage.
What other metrics provide such crucial early insights then?
Well, changes in machine cycle time are also incredibly telling. If the time it takes for a machine to complete a specific operation or cycle starts to unexpectedly increase or decrease, it can be a subtle but powerful indicator. It might show increasing resistance, growing inefficiency, or impending operational problems. It's a quiet sign that something is hindering the machine's normal, fluid operation. Pressure, particularly in hydraulic or pneumatic systems, is another vital data point. Deviations from normal operating pressure can immediately indicate leaks, blockages, pump issues, or other problems that directly impact the system's performance, efficiency, and longevity.
I can certainly see how those would be important, almost like a clogged artery or a struggling heart in a human body. What about energy consumption? That seems like a very holistic indicator.
Absolutely. Energy consumption parameters are highly informative and often overlooked. Unexpected spikes or drops in energy usage can be a strong signal of inefficiencies, maybe an increased load on the machine, or the early stages of component degradation. For example, a failing bearing might cause a motor to draw significantly more current just to maintain its set speed. Lastly, Meticulously tracking the number of cycles and operating time since the last service is essential. This helps predict component lifespan based on historical data and identifies machines that are simply nearing their service limits due to accumulated usage. This information allows for truly planned, rather than reactive interventions, scheduling them for optimal times. These data points, when collected continuously and analyzed together, they truly form an incredibly powerful, proactive diagnostic picture of your entire operation.
Okay, here's where it gets really interesting, I think. We've talked about the data, the sensors, the parameters, but the true game changer, the intelligent core that transforms raw data into actionable foresight, is artificial intelligence. AI isn't just crunching numbers, right? It's learning, predicting, and essentially giving us a crystal ball for our machinery. It's like having a team of thousands of expert diagnosticians working 24/7, constantly alert to the faintest anomalies. So how precisely is AI the intelligent core of predictive maintenance?
Yeah, AI's role is absolutely central. It acts as the indispensable brain that processes the nervous system signals, if you will. Its unparalleled ability to process and analyze enormous datasets faster and more accurately than any human is crucial for extracting real-time, meaningful insights from thousands of sensors across an entire facility. Imagine the sheer volume of temperature, vibration, pressure, and cycle time readings coming in every single second from hundreds of machines. AI can ingest and make sense of this data almost instantaneously. It detects patterns that are far too complex for human observation. This sheer processing power is foundational for truly predictive capabilities.
So it's not just about speed, though, is it? It's about more than brute force computation.
No, absolutely not. It's fundamentally about intelligence and learning. AI truly excels at learning and complex pattern recognition. It learns intricate failure patterns from vast historical data, not just what happens when a machine breaks, but the subtle, often imperceptible deviations that are early, pre-symptomatic indicators of damage or impending failure. These are patterns too nuanced and multidimensional for human observation to reliably detect. For instance, an AI might learn that a specific combination of slight, simultaneous temperature fluctuations and minor shifts in a vibration frequency occurring over a period of weeks reliably precedes a certain type of bearing failure, even if neither anomaly on its own would trigger an alert. It builds a comprehensive dynamic profile of what healthy looks like and flags anything that deviates from that learned norm.
So it's identifying the subtle dance of multiple indicators, not just isolated alarms.
Okay.
And what does it do with that intelligence?
And critically, AI doesn't just identify problems. It goes a vital step further by generating actionable recommendations. It can suggest which machines require intervention, what type of maintenance is needed, whether it's a simple lubrication, a precision alignment, or a complex component replacement, and even propose the optimal timing for that intervention to minimize disruption and cost. This allows for planned, pre-scheduled maintenance during existing downtime windows, rather than scrambling during an emergency breakdown. This capability directly enables the fundamental shift we discussed earlier, moving from a reactive failure model to a prevent failure paradigm. AI is the key enabler, truly revolutionizing operational strategy and empowering businesses to take proactive control.
That sounds absolutely transformative in theory, but where has this actually worked? Can you give us some tangible, real-world examples of successful PdM implementations that demonstrate this profound impact?
Yeah, definitely. And if we connect this to the bigger picture, these aren't just isolated statistics, These are concrete, quantifiable benefits that directly impact profitability, operational stability, and ultimately a company's competitive edge in the market. Consider a plastics production plant that embraced predictive maintenance by integrating vibration sensors and AI. They experienced a significant 35% reduction in extruder failures.
Wow, 35%.
Yeah, and the impact here wasn't just about saving money on emergency repairs, though that was part of it. It meant consistent product quality, because the extruders were operating at peak efficiency, reduced material waste from spoiled batches, and crucially, uninterrupted production schedules, ensuring they consistently met their customer demands reliably and on time.
That's a massive saving, both in direct costs and in the monumental headaches of unexpected halts.
Absolutely.
Yeah.
Another powerful example comes from a steel mill. Here, the implementation of predictive maintenance for their massive critical cranes resulted in an impressive 40% reduction in downtime within a single year.
Yeah.
In heavy industrial environments like a steel mill, where even a single minute of downtime can translate into tens of thousands of dollars in lost production and complex ripple effects across intricate operations.
Wow.
Well, those savings are truly monumental.
Unbelievable.
Furthermore, it vastly improves safety as planned maintenance inherently reduces the risks associated with unexpected equipment failure in such high-risk environments.
And it's not just in heavy industry, is it? Does it
Right.
apply to logistics and supply chain as well?
Not at all. Think about a bustling logistics center. By meticulously monitoring their extensive network of conveyor belts and vital elevators with PdM technology, they achieved a remarkable 20% increase in overall equipment availability. This directly translated to improved efficiency in sorting and moving packages, significantly faster order fulfillment, and enhanced customer satisfaction, because deliveries were made reliably and precisely on time. These compelling examples clearly demonstrate that PdM, powered by AI, is far from just a concept. It's delivering profound, measurable business value across diverse industrial sectors, from manufacturing to logistics, ensuring consistent, predictable operations.
So we've discussed the incredible power of predictive maintenance and the intelligent core of AI that makes it all possible. Now let's shift our focus a bit and look at how a platform like DBR77 brings all these powerful pieces together. From what I understand, DBR77 isn't just offering a single piece of software, right? It's building an entire interconnected ecosystem to help businesses step into this new era of digital excellence. They seem to be seeing the entire forest, not just individual trees.
That's precisely the vision, yes. DBR77 is a modern, comprehensive digital transformation platform specifically built to revolutionize industrial production and logistics processes. It emerged as a direct and urgent response to critical market needs that many traditional industrial firms face. These challenges include the pervasive problem of inaccurate or insufficient operational data, a significant lack of process automation, and a limited ability to adapt quickly and flexibly to dynamic market conditions. Simply put, traditional siloed methods are just no longer sufficient to meet the challenges of escalating global competition and the rapid pace of technological change.
And DBR77 aims to address all of those complex, interconnected problems.
Exactly. DBR77 tackles these pervasive challenges head-on by seamlessly integrating several core technologies. The Internet of Things, IoT, for precision data collection, digital twin technology for virtual modeling and robust simulation, artificial intelligence, AI, for intelligent analysis and forecasting, and an intelligent marketplace for automation solutions. All of these powerful components are brought together within one cohesive, unified platform. This deep integration enables real-time data collection, sophisticated analysis, and continuous optimization. It allows enterprises to quickly pinpoint bottlenecks, proactively minimize downtime crucially through predictive maintenance, and make agile, informed decisions based on robust empirical analysis rather than, guesswork.
Right.
Their core mission is truly ambitious: to empower industry to fully digitalize, transforming traditional factories and logistics centers into intelligent, automated ecosystems, optimizing every single aspect from strategic planning and execution to real-time operational control, all with a relentless focus on maximizing efficiency, ensuring unparalleled quality, and minimizing cost.
So, if DBR77 is this comprehensive ecosystem, how do its core technologies specifically support and enable that powerful concept of predictive maintenance we've been discussing?
Okay, let's delve into those key technologies, starting with the absolute foundation, DBR77 IoT, Advanced Data Collection Solutions. This is the backbone, right? The nervous system feeding the intelligence. Without robust, accurate, and real-time data collection, even the smartest AI and digital twin are operating in the dark. They can't generate reliable predictions. DBR77 addresses this fundamental need by providing dedicated, proprietary sensor systems. These aren't just generic, off-the-shelf components. They are intelligent sensors designed to be installed directly on individual machines and throughout entire production facilities.
What kind of precise data do these sensors collect, and how do they integrate with existing systems? That seems crucial.
Yeah, it is. These intelligent sensors meticulously monitor all the critical parameters we discussed earlier: temperature, pressure, machine operating time, vibration, energy consumption, and more. They deliver precise, real-time data that is absolutely essential for rapid decision-making in a PdM context. Crucially, DBR77's IoT solutions are designed for effortless, seamless integration with diverse devices and existing production systems. This ensures a secure, real-time data flow directly to a central platform for immediate analysis without disrupting ongoing operations. The benefits for management are significant: dramatically increased data accuracy, substantially reduced analysis time because the data is clean and immediately accessible, and lower data acquisition costs, all leading to better overall operational management and faster, more accurate decisions about maintenance and optimization.
That makes perfect sense. You absolutely need precise, reliable inputs for any intelligent system to generate meaningful outputs. Okay, next up is the DBR77 digital twin, the virtual replica for simulation and optimization. This concept sounds incredibly powerful, almost like a superpower, yeah? Allowing you to peek into the future and test things safely before making expensive real-world changes. It's truly a risk-free sandbox for innovation.
It truly is. DBR77 digital twin technology creates a virtual and mathematical replica of a real production plant or logistics center. Think of it as a highly detailed, living 3D model, but one that is constantly powered and updated by real-time IoT data streaming directly from the physical facility. This virtual replica accurately mirrors every production line, every machine, and even the intricate flow of materials within the physical environment. What's crucial, particularly in the context of predictive maintenance, is that this digital twin allows users to simulate various operational scenarios. You can model changes in a production layout, test new line settings, or, critically, simulate the impact of a specific component's failure using advanced algorithms and probabilistic scenario analysis.
So you can run what-if scenarios.
Exactly. Running thousands of what-if scenarios to understand the most likely outcomes and their associated probabilities without ever touching the live factory floor.
So it can not only predict how a change will affect the whole system, but also how a predicted failure might ripple through the operation.
Exactly. It can identify potential bottlenecks and, vital for PdM, forecast potential downtime by simulating the effects of a predicted machine failure or even the consequences of delaying a maintenance intervention. This empowers businesses to develop optimal implementation strategies for maintenance or other improvements without disrupting live operations. You can test the impact of an intervention or even the ramifications of not intervening in a completely virtual, risk-free environment. The platform's integration of virtual reality, VR, and augmented reality, AR, takes us a step further, providing highly realistic visualizations. Managers and engineers can effectively see and interact with planned changes in an immersive, realistic environment, significantly minimizing errors before any actual physical deployment. Within the context of predictive maintenance, it's about simulating what happens if a component fails, or how a specific maintenance intervention would impact the overall system's efficiency long before a wrench is even picked up.
And then there's DBR77 AI, intelligent decision-making and prediction. So, building on that incredible visual and simulation power of the digital twin, the next crucial layer that brings DBR77's intelligence to life is its AI. It's not just a diagnostic tool, it transforms raw data into strategic intelligence. So tell us, how does the AI go beyond just telling you if something might break to actually advising what to do about it and optimizing the entire operation?
That's the leap forward, yeah. DBR77's AI systems are the true data analysis powerhouse. They analyze the immense volumes of data gathered by the IoT sensors and the sophisticated insights generated by the digital twin. This allows them to provide truly proactive insights, not just reacting to events, but predicting them with remarkable accuracy. They identify subtle inefficiencies, predict failures, which is the direct and crucial link to PdM, and then suggest optimal courses of action based on their continuous learning from vast data sets. It's not merely a diagnostic tool, it's a dynamic strategic advisor.
Like having a virtual lean consultant on staff, around the clock.
Precisely. A built-in AI assistant acts as a virtual lean consultant, providing real-time, data-driven recommendations that help optimize entire processes, from material flow to production scheduling. And the system is continuously learning and evolving. Its machine learning algorithms continuously refine their understanding, leveraging vast historical, operational data to generate synthetic datasets for training even more precise predictive models. This leads to increasingly precise forecasts and deeper, more refined process optimization over time. Finally, the system also streamlines operations through automated reporting. It automatically generates insightful reports and recommendations based on advanced language models and statistical analyses, which significantly streamlines decision-making for managers and allows for dynamic, agile adaptation to changing market conditions and demands.
So, to bring it all back to our main topic of ending unplanned downtime, how does DBR77's specific predictive module utilize all this integrated power, the IoT data, the digital twin, and the AI to achieve truly robust predictive maintenance?
Okay, this is where the direct connection comes full circle, right? Where DBR77's high-level vision for digital transformation translates into a very practical, impactful module for achieving truly predictive maintenance. It fundamentally changes how companies approach uptime. This specific predictive module is offered as an integral part of the DBR77 IoT and digital twin system. It directly applies the integrated power we've just discussed. Raw sensor data from the IoT system is analyzed in real time by sophisticated AI models. This module's key functionalities include the automatic detection of impending failure risks and emerging trends. It doesn't just show you data, it intelligently interprets it to identify potential problems before they escalate.
And it provides those immediate critical warnings, right? So you know something's coming.
Exactly. It generates immediate alerts for necessary service interventions, allowing maintenance teams to schedule repairs proactively during planned downtime, avoiding costly surprises. And here's another incredibly powerful feature. It has the ability to simulate the consequences of delaying maintenance. This allows managers to instantly visualize and quantify the potential costs of inaction, whether it's lost production, increased repair expenses, or even safety risks. This module specifically supports rapid, informed maintenance decisions and drastically minimizes the risk of unexpected production stoppages, making the vision of ending unplanned downtime a tangible, measurable reality for businesses.
That makes perfect sense. And from what I understand, DBR77 isn't just about predictive maintenance, is it? It's part of a much larger, cohesive digital transformation ecosystem, seeing the entire journey of a business. So how does PDM fit into this broader strategic picture, and what other crucial components does DBR77 offer to empower companies across the board?
Yeah, this comprehensive suite truly illustrates how DBR77 views predictive maintenance not in isolation, but as an integral and central component of a much larger, interconnected digital strategy, ensuring sustained competitive advantage across all operational facets. For example, DBR77 offers a crucial tool they call their Digital Development Roadmap, DRD. Now think of this as your personalized GPS for digital transformation.
Okay.
This roadmap is designed to assess a company's current digital maturity, rigorously analyze market trends, and then create a detailed, step-by-step digitalization plan tailored just for them. For a company considering PDM, the DRD helps them strategically plan for and fully justify investments in such technologies, understanding precisely where it fits into their overall transformation journey and maximizing its impact.
And then there's the marketplace, an intelligent automation market. That sounds quite unique. What's that about?
It truly is unique. This innovative marketplace intelligently connects businesses with leading automation technology suppliers and integrators, using AI to provide personalized recommendations and transparent cost analysis. This is absolutely crucial because implementing an effective PDM system might, for instance, identify areas where new automation or robotic solutions are urgently needed to improve efficiency or prevent future failures. DBR77's marketplace dramatically accelerates the implementation of these solutions, shortening typical 25-month automation deployments by half and saving clients up to 30% of costs at the purchase and implementation stage.
Wow, that's a huge time and cost saving. And beyond the marketplace, DBR77 supports the actual deployment of these automation solutions.
Yes. DBR77 provides comprehensive tools for precise automation and robotization deployment. Their entire ecosystem directly supports these deployments and then meticulously optimizes their operational processes, which would then, of course, be monitored by PDM to ensure their continued efficiency and longevity. They also offer crucial financial solutions for CFOs, providing robust tools for comprehensive cost analysis of automation and robotization projects, detailed ROI analysis, and precise budget planning. This is absolutely crucial for justifying significant PDM investments by clearly demonstrating tangible financial returns and building a compelling business case for adopting such advanced technologies.
And it sounds like they cover the entire production and logistics value chain, not just one part.
They truly do. DBR77 has robust solutions for production and logistics that aid in automatic process measurement, meticulous material flow optimization, and deep operational efficiency analysis, all powered by the digital twins simulating various scenarios. As we discussed, PDM is a critical, foundational component of achieving overall production and logistics efficiency by minimizing disruptive downtime. They also offer crucial support for purchasing departments, with specialized tools for automatic offer comparison, objective supplier evaluation, and complete cost transparency, which significantly facilitates the procurement of not only PDM systems but all related components and services. Finally, their overarching focus on operational efficiency optimization through dynamic process analysis, value stream mapping, VSM, and material flow planning directly benefits from PDM, as it helps reduce major bottlenecks, unexpected downtime, and contributes to significant, measurable improvements across all these operational areas.
This sounds incredibly powerful and, frankly, quite comprehensive. But digital transformation, especially something as advanced and integrated as digital twin technology and AI, often comes with significant hurdles, doesn't it? Companies, particularly traditional industrial ones, can be wary of complexity and disruption. How does DBR77 strategically address these common challenges for companies looking to adopt new digital solutions and truly embrace this paradigm shift? Let's start with what often feels like the highest wall, the entry barrier for firms new to digitalization. So, are they essentially saying, you don't need to be a tech wizard to start, we've made it accessible, we'll teach you everything you need to know?
Precisely. That high entry barrier is a very real challenge. Many traditional companies lacking extensive prior digital experience may not fully grasp the profound value and transformative potential of digital twin and IoT technologies, which often slows adoption due to perceived complexity and, fear of the unknown. This results in delayed innovation and a reluctance to invest. DBR77's solution is rooted in their human-centric design philosophy, which ensures remarkable simplicity and intuition. Most functions are accessible and understandable after just a few hours of training, virtually eliminating the need for expensive external IT experts to get started.
Just a few hours, that's impressive.
Yeah. They also provide extensive user-friendly educational materials from practical case studies and their dedicated DBR77 Academy to informative webinars, all meticulously designed to simplify understanding and reduce those initial psychological and practical barriers. It's truly about empowering the existing workforce to become digitally fluent, not replacing them.
That's a remarkably smart and empathetic approach. But what about large organizations, the ones that already have vast, complex, entrenched IT infrastructures? Simplifying complex deployments in those massive organizations must be an entirely different beast.
Oh, absolutely. And this addresses a truly critical pain point for large enterprises: the widespread fear of ripping out existing mission-critical systems or facing years of complex integration. Large enterprises with deeply integrated ERP, MES, and WMS systems often face significant challenges when trying to integrate any new digital twin solution. The consequence is inevitably high initial costs and extremely extended implementation times due to the massive demands on their internal IT resources. DBR77 brilliantly addresses this by operating primarily in a browser-based environment, which significantly simplifies deployment because it requires no fundamental modification to existing core IT infrastructure.
So it sits on top, essentially.
In a way, yes. A carefully designed, robust API then enables seamless and secure integration with those existing ERP, MES, and WMS systems. Furthermore, DBR77's dedicated IT support team actively assists in these complex integration projects, meticulously minimizing both the time required for deployment and, crucially, the risk of operational downtime during implementation. It's explicitly designed to be a non-disruptive, highly integrative pathway.
And we talked about how absolutely critical data quality is earlier, the garbage in, garbage out principle. What if a company doesn't have great data to begin with or lacks the necessary IoT infrastructure? So they're helping companies not just with the software, but even with getting the right ingredients, ensuring the data itself is usable, even when starting from scratch.
Exactly. You hit the nail on the head there. AI and digital twin simulations are voraciously reliant on high-quality input data. If a firm has poor IoT infrastructure, fragmented data sources, or inaccurate data, the results will be unreliable, leading to a profound lack of perceived value and eventually discouragement or halted investments. DBR77 solves this fundamental challenge by providing its own robust hardware solutions, including intelligent sensors and comprehensive systems to support precise and reliable data collection directly from production lines and individual workstations. Crucially, they also offer a standard database that allows for initial simulations, even with incomplete live data. While certainly less precise without a full historical dataset, this initial simulation capability is often more than sufficient to identify major problems and immediate areas for improvement, providing tangible value from day one and building critical trust in the system as it grows.
That approach allows for a much softer landing and quicker proof of concept. Okay, but what about competition? The industrial digital space is crowded with giants like Siemens, ABB, Schneider Electric, you name them. How does DBR77 effectively carve out its space and compete with these enormous technology giants?
Yeah, that's a great question. It raises an important point about market differentiation and strategic positioning. DBR77 carved a powerful and highly effective niche by prioritizing accessibility and rapid value delivery, which ultimately broadened its appeal far beyond its initial target. Initially, DBR77 strategically focused on the vast small and medium enterprise (SME) sector. This market segment is often overlooked by larger providers who tend to target only massive, complex, and highly lucrative deployment.
But a big fish.
It's exactly. The simplified deployment model and the promise of rapid ROI were profoundly attractive to SMEs, who often lack the extensive resources of large corporations. However, this very approach unexpectedly attracted larger corporations as well. They began to realize and value DBR77's inherent flexibility, simplicity, and significantly lower subscription-based entry cost, which contrasted sharply with competitors whose complex, bespoke deployments often cost hundreds of thousands, if not millions, of euros up front. This allowed DBR77 to gain significant traction by offering a more agile, cost-effective, and quicker-to-value alternative.
It sounds like they found their niche, proved their model, and then naturally expanded from there. But industrial clients are notoriously known for having very long, multi-stage decision cycles for new technology adoption. How does DBR77 accelerate these lengthy processes? So instead of demanding a huge leap of faith, it's more like a series of confident, data-backed steps, each one proving the value.
That's precisely the core of their acceleration strategy. Industrial clients typically do have lengthy, multi-stage decision processes for new tech adoption, involving extensive testing, detailed ROI analysis, numerous layers of internal approvals.
Yeah, the bureaucracy.
Right. This often results in frustratingly delayed sales cycles and prolonged negotiation processes. DBR77 directly addresses this by emphasizing pilot projects. These pilots allow clients to test the solution on a small, manageable scale in a real-world environment and quickly verify its tangible effects and benefits without committing to a full rollout. The subscription model also helps significantly, as it avoids high upfront capital costs, which is a major accelerator for initial decisions and reduces perceived risk. This low entry barrier, combined with a high return on investment, quickly demonstrated in a successful pilot, strongly encourages full implementation after a trial. It truly is about building confidence step by step, with data backing each one, showing immediate value.
That makes perfect sense. Another crucial challenge in this complex industrial space must be building and sustaining a robust network of integration partners. How does DBR77 tackle that, ensuring companies have the support they need to implement these solutions effectively?
Yeah, and this showcases a critical understanding of the industrial landscape. Technology is only as impactful as its effective and skillful implementation. Effective digital and automation solutions absolutely require collaboration with a broad, diverse ecosystem of technology providers and integrators. A lack of a developed ecosystem can severely limit the availability of expert implementation services, leading to slower processes and increased costs. DBR77 solves this by operating a vast, dynamic marketplace that meticulously connects manufacturing companies with over 800 technology suppliers and 600 integrators, making it the largest platform of its kind globally.
Wow, 800 suppliers and 600 integrators.
Yeah, it's extensive. This continuously expanding partner network provides instant access to specialized expertise in a one-stop-shop model, which profoundly benefits both clients who need support and the integrators themselves who gain access to a continuous stream of new projects. DBR77 built the essential bridge between the solution and its expert deployment.
Data security is, understandably, a huge concern, especially when dealing with incredibly sensitive operational data and proprietary factory processes. How does DBR77 address cloud data processing and security concerns? So for companies dealing with incredibly sensitive operational data, they've clearly prioritized the trust factor and comprehensive security measures.
Absolutely. Industrial firms processing sensitive operational data inherently have profound concerns about cloud security standards and strict legal requirements, such as GDPR compliance within the EU. This perceived or actual limited trust in cloud solutions can significantly delay or even outright prevent platform adoption. DBR77 has implemented robust, multi-layered solutions. Their entire system operates in accordance with the highest international security standards, specifically ISO 27001, which is a gold standard for information security management. All data is meticulously stored on AWS servers located in Frankfurt, Germany, which ensures full compliance with GDPR requirements for data protection within the European Union, providing a strong legal and technical framework for data sovereignty. Furthermore, it's a strictly B2B platform where all users sign mutual non-disclosure agreements, NDAs, legally safeguarding not only production data but also sensitive intellectual property shared by integrators and technology providers. This holistic approach builds significant foundational trust.
International expansion must present its own unique set of challenges, right? With vastly different legal regulations, tax systems, technological standards across borders. How does DBR77 navigate the complexities of international expansion?
Yeah, this strategy highlights the paramount importance of adaptability and leveraging existing networks to overcome the inherent complexities of international market entry. Diverse legal regulations, intricate tax systems, varied technological standards across different countries can indeed significantly impede the process of entering foreign markets, potentially slowing down expansion into key regions like Germany, the USA, or Asia. DBR 77 proactively addresses this by actively collaborating with established local integration firms and technology distributors. Many of their current partners already operate internationally and possess deep local knowledge, which significantly simplifies the adaptation of the DBR 77 solution to specific local requirements and accelerates their global expansion efforts, leveraging established networks and expertise, reducing the friction of international adoption.
And finally, clients, particularly the industrial ones, always want to see a quick, demonstrable return on investment. How does DBR 77 meet these high ROI expectations from clients? It seems like every solution DBR 77 offers circles back to demonstrating real, measurable value quickly, which is exactly what businesses need to see to justify investment, isn't it?
It really is. That's a fundamental pillar of their entire strategy, and they recognize its critical importance for long-term client relationships. Industrial companies prioritize strong financial indicators and tangible outcomes above all else. If they don't see quick and measurable savings, they may quickly discontinue subscriptions or halt further investment. DBR 77 understands this necessity for consistent value demonstration. Their solution integrates a low initial cost, significantly facilitated by the subscription model, which inherently contributes to achieving a rapid and high return on investment by minimizing upfront capital expenditure. Additionally, the integrated marketplace helps clients select optimal solutions and technologies precisely tailored for their specific plant, significantly shortening implementation time and therefore dramatically increasing the likelihood of quickly realizing tangible benefits and solidifying the long-term relationship.
And how do they ensure they're always staying ahead of the curve, given how fast AI and digital twin technologies are evolving? I mean, this space is moving at light speed.
Yeah, and this addresses the crucial aspect of long-term viability and competitive edge. DBR 77 isn't just building great technology, but has a built-in continuous mechanism for innovation and relevance, ensuring it remains at the absolute cutting edge. AI and digital twin technologies are indeed evolving at a rapid pace, and companies that fail to keep up can quickly find their competitive advantage eroding. DBR 77's dynamic approach inherently benefits from the platform collecting vast amounts of data, both real operational data from its IoT systems and synthetically generated data from its digital twin simulations. This enormous and ever-growing dataset serves as an unparalleled training base for its AI algorithms, allowing them to continuously learn and improve. Furthermore, direct collaboration with technology suppliers and integrators within their marketplace ensures that data on new equipment and the latest solutions are constantly updated within the platform. DBR 77 also includes advanced spatial analysis functionalities, allowing it to work with the very latest AI models, consistently positioning the platform at the forefront of industry innovation and ensuring its future relevance. #outro out.
So to recap our deep dive today, we've explored the profound power of predictive maintenance in eliminating costly, unplanned downtime, a pervasive problem that plagues, well, so many industrial operations. We've seen how a holistic ecosystem like DBR 77 brings this to life, combining their precise IoT solutions for data collection, the powerful digital twin for simulation and optimization, and advanced AI for intelligent analysis and proactive recommendations. It truly provides a comprehensive, accessible, and highly effective solution for this critical industrial challenge.
And for you, the listener, the profound takeaway here is the transformative shift from reactive crisis management, that frustrating cycle of waiting for things to break, to proactive, data-driven operational optimization. This means not just significant cost savings and dramatically increased efficiency, but also greater stability, predictability, and a lasting competitive advantage that truly empowers businesses to take control of their future and achieve uninterrupted operations.
So for you, the learner, consider this. What single piece of equipment or critical process in your operations, if it never unexpectedly broke down again? What would that mean? How would that truly revolutionize your efficiency, your bottom line, and maybe just your peace of mind? And how might a deeper dive into these remarkable technologies uncover surprising new pathways to that uninterrupted, optimized future you're seeking?
Yeah, and for those intrigued by the possibilities and genuinely curious to see this technology in action, DBR 77 offers direct pathways to explore further. You can register on their platform for a test, contact their sales team for access to a demo version, or even arrange a personalized demo meeting to see precisely how this technology can specifically benefit your unique situation and challenges. All those details are easily found through their main channels.